Greetings and welcome to another C# Live coding session. We are working on a Minecraft server launcher, and last time we managed to implement remote console access, which is supported by all versions of the Minecraft server, at least all of the recent ones. The initial server builds didn't. But by having remote console access, we can actually issue commands in the server console as if we were actually engaging with the built-in UI. In any case, I did a little after streaming code cleanup and documentation, and then posted last week's update on GitHub, which of course is available there. I might go through the same process today just to make sure that everything that we do today gets properly documented before I push it to GitHub. One thing that I did last time was I did a little bit of code cleanup on the ini file class, as well as adding all the documentation to it. One thing that I changed was the property that controls virtual grouping. And the reason for doing that was because I wanted the ini-file class to be a little more multi-purpose or general purpose than it was before. So we now have, instead of the Minecraft server properties naming of the property itself, it's now called virtual grouping. And internally I added a virtual group name. I also updated some of the methods, the getValue method as well as the setValue method to effectively only accept a key name, but only while in virtual grouping mode. The reason for doing this is so that we can do a quick update of the server host thing. See, here we have the server properties update method that changes the contents of the server properties for the Minecraft server before starting it up, and in a similar fashion and does a cleanup after the server has shut down to remove any kind of Archon information that might have been put in there. One thing that I do need to check quick is whether I updated the remove. And yes, I think I did. No, I didn't. I didn't because it would conflict with the name of the group. So for these two, we still need to leave them in with the prefix of an empty string for the group name. But due to the updated overload of setValue, we no longer need to specify an empty group name. So I'll get rid of these quick. There we go. And the same down here, and that takes care of this fix. It's not a particularly huge fix, it just adds in a little bit of convenience. All right. So today we are going to do quite a bit of house cleaning on our project. I've got one more nicety feature that I would like to implement, which will be having the console parser pick up when players join and when they leave the game. And of course the current messed up UI could probably stand to be changed quite a bit. At the moment, it's, to put it mildly, just a huge mess. So we're definitely going to do some house cleaning on that and see if we can come up with a better UI design. And while we're on the topic of UI, further down the line, as part of the new feature implementation of keeping track of who's online, the online list that we will be creating later on, I've got a little UI magic planned for that. So let's dig into it and see what we can get done. All right. First of all, we don't need to look at this anymore, but we definitely do need to have a good solid look at this. Now, this is the actual console parser. What this part does is it reads all of the text lines that come from Java while the server is running. We effectively split each individual line so we can detect the log level and grab some other information so we can determine specific states of the server. For this particular setup, we are looking for a log line that contains the word done and also the text for help type. This will be the last line that the server outputs once the world is properly built and ready to be joined. So this helps us to detect when the server is actually ready for players to join in. And to tell the rest of the program that this has occurred, we raise the event on server started, or the server started event, sorry. Another thing that we are looking for is a verification that the remote console Archon service is now up and running. And once we detect that, we tell our remote console class to attempt a connection on localhost with whatever console port was configured along with whatever password was put in there. And the last thing that our current console parser does is it looks for a log message stating that the server is now stopping, so that we can properly disconnect from the server, the remote console connection, disconnect that from the server, and then inform that we are now shutting down. All right, so to add in some kind of check that tells us whether a player joins or a player disconnects, we kind of need to take a look at our, let's see, logs, which we have right here, and see what's actually thrown in here. Now, this is the log line that tells us that the server is done loading. Here is an example of me joining the game, and here is an example of me disconnecting. So these would be the ones that we would need to be able to detect. Now, we also know that there are certain problems with detecting text like this, and those problems involve what if the player actually enters something like this, for example, in the chat. Now, one thing that we can do is have a look at how the Minecraft server handles chat messages. So let's start it up manually and see what goes in chat. And here we go. It's now up and running, and we can now connect to it. So let's log in. There's the login messages, and just for the sake of argument, let's grab this and see what happens. We want this, and then boom, logged in with entity ID. Now, as you can see, for a regular vanilla server, chat names are wrapped in less than and greater than symbols. For a plugin based server, these may be changed. But regardless, we know for a fact that there is a specific format to how these things are actually handled. And that format is that we can see that initially we get an instance of user authenticator, and then however many logins have happened since the server was restarted, it runs at info level and starts out with the UUID for the player, which means we can start by splitting this out and use that as a player is now connecting. We also know that whenever the player is actually connected, we get in brackets an IP reference, which effectively could be put in chat. We also know that it tells us an entity ID specifically, and some reference to where in the world this particular player logged in. So we can search for these pieces of information specifically, and then I guess assume that if we see this as the following chat message right after the user authenticator triggered, then this would be the only instance we need to check, and then after that players can throw whatever they want in chat, even grab an exact copy of what the console threw out, and we shouldn't trigger on that. The thing is that the server thread info shared an IP logged in with entity ID blah will always trigger as the second line after, or as the first line after the user authenticator kicks in. So that would definitely be the place to look for it. All right, let's disconnect from here and shut down this thingamajig here, just in case. Boom. Now, this now gives us a workable log. And just to keep a copy of it, get rid of this one, and then grab the copy. There we go. This will then help us a little bit at trying to parse all this stuff when we get to that point. First of all, we should probably do something about how console output is actually handled, since we now also need to know which particular thread issued the log message. At the moment, the only thing that we do in parsing the console output is split here and look for the log level by trailing back the slash and then grabbing whatever message was associated with it. Since we now specifically need to look at things like the user authenticator thread, that also means we need to split which specific source this particular message came from. So we'll do a little bit more text parsing and splitting here, and see if we can come up with a good way of grabbing this information. Now, any console message that's dumped is always prefixed with a timestamp followed by source/thread with a log level followed by whatever message was output. So with that knowledge, we should be able to build up something that can split the timestamp, the source and log level, and the message itself, which will hopefully make it a little easier for us to actually figure out what's going on. All right. Instead of having all this parsing stuff sitting here, I'm going to create a, let's see, get rid of this here. I'm going to create a separate method that handles all of the console parsing, as well as a structure that will contain the individual parts. Personally, I heavily dislike using regular expressions. It's a convoluted setup that nobody understands, and in terms of using external libraries, it's something that I generally try to avoid because it makes my product dependent on somebody else's code. And all too often before, I've run into situations where I have been unable to update my product because of some external library not being updated, which leads to me having to deal with users requesting an update that I can't deliver. And hi to you too, Sir Pinwheel. Good to see you again. All in all, doing particular text parsing is actually a very valuable skill to have, because it allows you to build up whatever search elements and whatever split elements you need to without having to rely on some external library somewhere. Plus, it gives you a better feel of what actual message parsing is. So, anyways, let's see if we can get something split here. Console parser. All right, so we know that we would like to have the timestamp. We know that we would like to have the source and log level, and also some kind of container for the actual information that was posted along with this particular log entry. So we want the timestamp, we want the source or thread, we want the log level, and we want the log message. So that makes up 4 individual parts of each individual log line. So for that, we are going to create a private structure. I'll call it log entry. We know that we want some kind of timestamp. We'll use a date for that, since why not? We need a source, which should be a string. So we'll call it source. We also need a log string for a log level. The log level we could probably convert into some kind of enum. However, there is a major difference between how vanilla servers output their log levels, how plugin based servers, depending on which specific plugin server you're using, as well as how the Forge servers output the different log levels. There are different categories, and each server effectively implements its own custom sets of log level categories. So if we were to try to support this through all of these different kinds of servers, we would effectively need to investigate each individual one to be able to build a proper enum for it that supports all the different log levels that each individual server outputs. So for now, we'll just use a string for it. We also need to add in for the actual log message. There we go. And just for the sake of being able to assign the values right away, we shall do a datetime timestamp string source, string log level, and a log message. There we go. Timestamp. Grab that. Grab the source. Grab the log level. And the, oops, there we go. Should probably also trim this just in case. And the log message. There we go. Alright. Next up, we need to build a parser that takes the one string that comes from Java, which would be right here, and splits it into these four individual subcomponents. So we will return a log entry, parse console line, string line. I'll call it console line. There we go. All right. So let's have a quick look at the actual log outputs again. And for the sake of having them here, I will throw them in a comment quick, just so we can more easily reference them. I'll grab this one. There we go. Okay. In case you don't know, the UUIDs of any player that has a Minecraft account, this part right here, is publicly available to anyone. There are tons and tons of different sites that can convert any Minecraft player name into the associated UUID. So in terms of keeping your personal UUID secret, it's kind of pointless because it's openly exposed everywhere. Yeah, we'll keep this in here as well. All right, so what we can determine from this is that we will have at least two instances of the brackets. The first instance contains the timestamp. The second instance contains the source and log level. These are identical across all Minecraft servers, regardless whether it's a vanilla server, a plugin-based server, or a Forge modloader server. They are identical. In terms of detecting players connecting, disconnecting, the server starting up, the server shutting down, for the most part they are also identical across all the different kinds of Minecraft servers. There are of course some additional things that are output as part of the Forge servers for modded instances. However, the one thing that seems to change a little bit between versions is how the server reports that it's now shutting down. Some of them report both of these lines, some of them only reports one of them, some of them only reports the other of them. So to make sure that we can properly detect that the server is shut down, we will be looking for both of these text instances. Other than that, this one is identical across all servers, and this one is identical across all servers. However, plugin-based servers may have manipulated the output of this one particular log entry. Those are the ones that change the join and leave messages. This particular line is the one that's shown in chat when a player disconnects. So the one that we should look for to ensure that we actually detect a player leaving would be this one, because this one is coming from the server itself and is not displayed in chat. All right, let's get back to a little bit of text manipulation. All right, so the first instance of the brackets will be the timestamp, so we will be looking for that. And one thing that we can do to make this a little easier for ourselves is grab a page from the old text parser, which looked for the close bracket followed by a colon, which is what we have right here. So this one should always exist. I have yet to see an instance of a server log that doesn't include it. I doubt it will ever happen. But in this particular setup, we are splitting them according to we're splitting them according to the close bracket followed by the colon. So this would be the quick and dirty way of splitting the raw data from the actual message itself, and then we can process the raw data afterwards. All right, so to begin with, to ensure that we don't run into some kind of crash problem if what we assume is there for some reason isn't there, we'll do the check console line. Let's look for the close bracket and colon. The reason for doing this particular setup is just to ensure that we actually have what we expect. And down here we will return a new entry, log entry, date time.now, nothing, nothing, and nothing. There. So if for whatever reason we don't get the close bracket colon, we'll just return an empty log entry with the current date and time. All right, so let's do the raw data first, which would be console line. We need a substring of it, and we of course need to start at the beginning. Actually, let's save ourselves a little bit of typing, because this already does it for us. So let's grab this and go with raw data here instead. We'll need to change this to console line, of course. Console line, there we go. And this we don't need, because we actually need to split the raw data into a lot more. So this would be the actual log message. So let's grab this. There we go. All right, so this takes care of grabbing whatever is here, or here, or here. And since we've got a trim on it, we can always be sure that any leading and trailing spaces are removed. So we don't particularly need to do any extra work on that. Now for this part, I would like to have the oh, actually we don't need that. This should be good enough. This will grab, let's see, this part right here, ending at the last character of whatever is in the source and log level bracket set. And since we know for a fact that we will always get it in this format, we can start by grabbing a source info and do a substring on the raw data, because we know for a fact that the starting bracket exists twice. We also know for a fact that there is no trailing close bracket because of how we've set up the initial substring of it. So we will simply just grab from the end of the string, search for the first occurrence of a opening bracket, and that will then leave us with the source, the slash, and the log level, and only this text. So that's pretty simple. So let's grab the raw data dot last index of, search for the open bracket, and we will begin one character past it to start at the first character within the bracket, and then simply grab the length of raw data minus this particular position, and we now have source information. The last remaining thing that we need to do here to get the actual source and log level is to effectively split the slash, and that's it. So pretty simple and straightforward string manipulation searching. Let's see. We will grab, just for the sake of argument, we'll do a source parts and do a source info.split. And yes, I know that this can be simplified, but for the sake of readability, I will keep it set up at individual parts. I should probably put in some comments here just to describe what this actually does. Grab a copy of the start of the console line ending at, there we go. Grab a copy of the log message from the console line starting at, there we go, and starting just past, and remove any leading and trailing spaces. Oh, actually, I forgot to resize the editor. I do apologize. Let's see. I can't remember what I had it on last time. Sorry, guys. Is this better? And okay, so here, grab a copy of the raw data. The last part of it, starting just past the last there to the end of the string. There we go. Now that we have source info, we can simply split on the slash to get source and log level. So let's grab those. The source, which would be source parts 0, and the log level, which would be source parts 1. We know for a fact that this slash will always be there. It's always been there in every single log file that we've looked at. Even the shutdown thread thing, it's in there, so we can pretty safely assume that it'll always be there. Okay, so we now have the source, we have the log level, and we have the actual message. The only thing missing is the timestamp. So lastly, let's grab the timestamp. Now the timestamp itself is in the initial bracket set, which means that we can safely assume that we always have a open bracket and a closed bracket at the beginning of the string. So that helps us in splitting out the timestamp. So let's grab the timestamp from the raw data. We could do it from console line as well. It doesn't matter what the source is. However, raw data is by default shorter, so less memory operations. So let's grab it from that one. And for this, we need to start at the beginning and look for the first occurrence of the close bracket. So we shall do the index of, looking for the close bracket. And since positioning is 0 based and length is 1 based, just applying the position will grab the string at the last character of the actual timestamp, meaning this position. So now that we have that, remove the leading bracket. We can do that by any means we see fit. For the sake of simplicity, we will simply just do a replace. So replace the open bracket with nothing, and then just in case, do a trim. There we go. Last part is then splitting the actual timestamp itself into its 3 components: hours, minutes, and seconds. We know that it's, at least to some extent, padded. So we can always assume that every timestamp will always have 2 digits for each. And since we know that it's divided by colons, we can do another split. Split the timestamp parts. So timestamp parts, these equals timestamp that split, and split by colon. This then leads to us having 3 individual strings, each containing the time components, which is hour, minute, and second, in that order. Next part is then doing a little bit of string to numeric conversion, and for the sake of doing things a little easier for us, I'll add in a quick fix numeric for us, or fix int. Fix int, and then do a string value. The only thing that this does is effectively just make it quicker for us to convert the string into an integer, which we will need to properly generate a correct date time to put on there. So the method of converting text into a number is by using the try parse. This will attempt to pass whatever string is passed into the actual numeric variable that the method is called on. In this case, we'll use an integer. So here it tells us that it will actually return a flag that tells us whether the conversion process was successful or not. And it takes a string in, and yes, we can do that, absolutely. Hi, Joburn. The reason I'm doing it this way is to give you an indication of doing actual number conversion, so you can later on pass whatever numbers you need for whatever purpose. We can definitely do the parse exact. It's the quick way of converting it. This is just to showcase that there are other methods available for converting the numbers and then creating the date. I will add the other way of doing it as a comment in the code and leave it there. In any case, we know that it returns a boolean, so if it's not successful, out result, then we will force the result to be 0 again, and then we will return whatever came out of this. Try to parse the string as a number. If not successful, force the result to 0. Whoops. There we go. This one will effectively convert any string that fits an integer, attempt to convert it into an integer. All right. Let's see. Here. I'm full of keyboard derping today. Sorry, guys. Attempts to convert the passed string value into an int number. The value to convert returns and the integer representation of the passed string if successful, otherwise 0. There we go. All right, so convert the 3 time components. Int hour equals fix int. Since we know that the hour will be shown first, we'll grab that. Minutes, fix int, timestamp, parts, that would be the second one, and the seconds would be the third one. There we go. All right. As 144 suggested in chat, this is the faster way of converting the timestamp. let's see, this would then be date time log date equals date time dot pass yep, I'm from Denmark. Where was I? Pass. Let's grab this quick. I'm a little bit on the derpy side of things today, so would be the timestamp followed by the minute, oops, hours, minutes, and seconds. There we go. This should take care of it. Oh, actually, it needs some kind of additional stuff. Let's see. Format, time style. Does it actually need all that junk? Yeah, it does. Yeah, we'll move it up here. There we go. Can't be bothered. All right. So we now have the actual time components. We've got the source it came from. Oh, yeah, absolutely. You're correct. Let's grab it here again, just to. And it's the culture info. My brain is somewhere else today, I think. Culture, right. Culture info, which is in the globalization. In Marin culture. There we go. That's the one. Thank you very much. Yeah, I know. Half the programmers of the world like it on the white, and half the programmers of the world like it on the dark. It's difficult to put everybody, or to please everybody, sorry. There we go. All right. We should have all the parts of it needed, so might as well give it a try and return it and see what happens. All right, so we need to return a new log entry. We need a new, fair enough. Date time. Now this takes a crap ton of stuff. So, just for the sake of it, we will add in date time dot now dot what did it want first? It wanted year, month, day. So let's just, for the sake of it, grab year, time now, month, day, then the hour, the minute, and the second. And there we go. That's because I forgot an E up there. There we go. All right. The next part would be the source, followed by the log level, finishing off with the log message. There we go. And we're good. Well, it's almost 1 in the afternoon in Denmark, so it's pretty bright. But we can switch to dark theme if you want. I honestly don't care which way it goes. Let's see. Options. Go with the dark. There. Is that better? All right. So we are now hopefully getting a log entry from this particular method, which has all of the individual um, dark equals pro. That's what some say. I would humbly suggest that having the code skills equals pro. The color scheme doesn't make any difference. All right, so ba-da-ba-ba-ba-ba. Now that we have a method that takes care of splitting all the stuff, we can basically get rid of a lot of the stuff that we have sitting down here. We could potentially also change the console changed event to let us apply these four components. Where is it? Right here. The actual timestamp, the source, the log level, and the log message. In essence, the Minecraft server itself generates its own log file, so whether we actually need this information for further processing or buffering, well, kind of depends what we want to do with our particular server launcher down the line. If we end up effectively, let's say, converting this into a Windows service that we can install on an actual Windows server, and then say, for example, do a local network TCP connection to it and control it remotely like that, then it might be interesting to buffer all the log entries of each individual server instance that it's currently running, so we can request that information and take it from there. Thank you very much for the follow, Anti-Fufu. In any case, for now, we'll go down and fix up our console processor. So, we know that we are triggering this as the very last thing. This would be the check to see if there actually is a close bracket colon. This might still be interesting to have in here just in case. Again, one of those things when we're dealing with substring and searching for stuff, we kind of need to be sure that it's actually there. So we'll leave this in for now. Okay, all of this we will put a quick reminder. Look for done and for help type because we need to raise the server started event. We also need to look for Archon running on to start the Archon connection stuff. And finally, we need to look for these two messages, stopping the server and stopping server. So 3 and grab the other one. Server shutting down, which would be D. shutting down event. Alright, so all of this stuff here well, we will eventually get rid of. Then we will do a, whoops, grab a log entry, parse console line, there we go. That's pretty much it. Now, we know that the done and for help stuff is posted at log level info, as can be seen right here. And we also know that it comes from the server thread, so we can look at those. Let's start by, hang on a sec, let's see. We want to look for a couple of different things. This one runs on a different setup, which would be, I can't remember. We'll see. Alright. Yeah, we'll need all the other stuff. So later. Yep, let's grab this. If entry.log source equals server, was it uppercase? I can't remember. No. It was uppercase server, lowercase thread. So since we want to look for these regardless, we'll just lowercase it. That way we're pretty sure that we always get it regardless whether the server has one of them uppercased, both of them uppercased, or both of them lowercased. Quick fix. Alright. We also need to look for the other one. If the Archon listener thread can't remember the output. There we go. Alright, so if it's the server thread, we can look for the done and the help, so we'll do that. If entry.log message yeah, I guess we could do the initial. We'll do it similar to this. That's good enough, I guess. Grab this. That would then be entry log message. And it contains an index of this. And this we should probably also lowercase, just in case. We never know when they decide to change something. So let's do the to lower, and then lowercase this, and look for a lowercase version of this as well. If this is the case, raise the server started event. That takes care of first one, which would be this one, so we can get rid of that. It's done. Next up, we may want to look for the stopping, just to keep these two together. So we'll grab that, stuff it in here, and then convert it to our log entry and do these lowercase again. copying server. We still use this to avoid the event triggering twice. We still need to disconnect from the server with the Archon, and then we can raise the server shutting down event and indicate that we have already completed this event handling. There we go. And finally, we also need to look into the Archon running on. However, I can't remember the source name for it, so we'll do a quick run and see whether this is actually working so far. And for that purpose, we shall grab this part. Sir Pinwheel. Yeah, well, I have actually been considering, just for the fun of it, as the next project, to try and see if we can build an old school mod server that's effectively a telnet game server for role-playing games. That would showcase things like how do you handle a sort of simplistic server setup that can accept multiple connections in. How do you handle an actual environment where multiple different connections interface to one common world? How do you handle communication across, say, two different network connections to show things like private messaging across the server, stuff like that. But I'm definitely open to suggestions, requests, so don't be shy. Please feel free to come up with suggestions, something you'd like to see, and we'll go from there. As a small side note, I'm currently working on setting up an actual media site for all of these different projects and streams and parts of streams that I've uploaded to YouTube. So at some point I'm going to post a link to that site where I will try to keep all of the cross-site links posted, along with an open suggestion box that anyone can put suggestions into, and I'll go through them, and if I feel a suggestion has merit, then I'll do some streams on that too. But it's still in the works. We need this part, so just to keep that, we'll put it here. There we go. And then we can get rid of the rest of this stuff. There we go. Well, the way I see it, one of the most common questions I get from new developers or past novice developers is, how do we do networking? How do we do server setups? Can we do server setups? How do we do client stuff? How can we create a client that connects to a server and throws out some events when something happens, and so on? And since a mod server, that's spelled MUD, for multi-user dungeons, it is the precursor to the graphical RPGs that we know today. But since a mod relies strictly on plain text, and also on things like the server handling actual network sessions and so on, I thought that would be a pretty good idea to showcase the basics of how to do network communication. There's nothing complex in how the server and client communicates because it is literally plain text. So da, 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 da. Pass it. Yeah, true. All right, so here we still have the entry, so let's throw that in there. This should then still keep our event stuff running. The one thing that it won't do at the moment is start up the Archon, since we are not yet parsing the Archon text. However, let's see if we can fire this up and get the information. Keep in mind that the server launcher will still have the Minecraft server put up its own GUI. This is strictly for verification and testing purposes, and something that of course will be removed later on. So let's see if we can start this stuff. Pooh! Only available in virtual grouping mode. Huh, see, we forgot something. So let's have a quick look at this and see where we derped up. Let's see. Da -da 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 -da. This should be fine. It would then be in the update stuff up here somewhere. Meetings. Oops, that's the main form. It would be up here that we need to internal helper methods, update server properties. This one needs to be set in. Oh, it actually should have been set to virtual grouping, which means there's a bug in here somewhere. That's weird. So it's actually setting it. The typical crap. Alright. Me no trusty C# sometimes. Virtual grouping. See, it's supposed to set the property, but for whatever reason it doesn't. Yeah, the property bag. Ugh. Alright. Then we'll do this instead. Let's grab this quick. Oops. That one we didn't need to change. That one is set. That one is here we need to change it, and there should be another one right here, and this should take care of it. Almost. And one more. And one more. And one more. Set these. There we go. Now let's see what happens. Still? What? Why is that false? That is a maybe it's because of the load. Let's see what the load does. Yeah, it sets it to false, hence why it's forced. So we need to put it here instead. Or do we need to put it in both? Yeah, we actually need to put it in both, because the parser depends on it, so we shall simply set it twice. Take care of that problem. There we go. Now, the standard vanilla GUI doesn't tell us the source of it, only the log level. But since we're dumping the raw information in our output, this tells us that the source is the Archon listener, which is set right here. And it is suffixed by, I guess it's either a thread count or a startup stop count. Not particularly sure what this number 1 indicates. In any case, we can look for this. And again, we're not entirely sure whether this will always be uppercase, whether part of it will be lowercase, whether listener will be upper or lowercase. So when searching for it, we'll simply just lowercase it. But that is the source that we will be looking for. So since the Archon is currently not running, from our application, we'll do a shutdown here. Boom. There we go. And we'll kill this. All right. This would be down here. So let's see. This would be the source. And right here, we found out that the output was Archon listener number 1 at info level. So that's what we need to look for. All right. Get some coffee. After all, a programmer is a tool for converting caffeine into code. Okay, so we know that there should be a hashtag in there. There can be a hashtag in there. We don't know for sure. So we will simply just see if we can find this as part of the source from the log entry. So if the log entry source to lower index of Archon listener, then we can pretty safely assume that we now have an instance of Archon running. But just to make sure, we'll do the same verification of the actual chat message. So let's grab the log message and search for archon running on greater than -1. We should be good. Yeah, I have looked at a couple of bots, but so far I'm a little nah. Well, we'll see. Maybe we'll do a bot of our own as a separate project. We'll see. All right. So before we checked to see if the port that was posted in the log entry matched the configured remote port. And from there, we then fired up the connection if we found a match. So I'm thinking we might as well do the same thing here. It's always a good idea to verify your stuff. So let's grab this, move it up here. There we go. And then we can get rid of this stuff. All right. So entry.log message. We know that it contains a colon somewhere that we need to fetch. There we go. And then we can do the fix int since we now have it. This is the good example of why I created the fix int method in the first place. So we will simply just do fix int port info. There we go. Then we can get rid of this. And we know that we will always get 0 or whatever's in there. And do the comparison. Is the console log shown port identical to our configured port? There we go. And fire up the archon. All right. Well, I guess you would call this classic .NET. I honestly haven't messed much with the core stuff just yet. I might not have gotten the full briefing on what core is, but so far from what I've seen, it's kind of pointless. But again, I may be misinformed. Having said that, I'm an actual old school a real old school developer. I did my initial software development in DOS back in the day, way before we actually got a graphical user interface. I've done development on the Windows 3.x series, including the Windows, the 16-bit Windows for NT, before we ended up getting things like Windows 95 and XP and so on and so forth. So a lot of the techniques and stuff that I use are rooted in how things had to be done way back then, because back then we didn't have this overly excessive amount of helper libraries and helper methods and all the other junk. So I kind of tend to avoid using a ton of different libraries for a ton of different things if I know that I can, how should I put this, fiddle my way out of the code instead. So anyways, we did some changes. As a good programmer always should, test your changes, so we'll do that. Let's see if we can actually get this stuff running and have it stop again. If this is working correctly, then the stop button should at some point be enabled. There it is. And the reason the stop button gets enabled is A, because we got the server started event, as well as the correct interpretation of the Archon listener starting up. And as you can see here, instantly we got a connection from localhost. So we are actually connected to it now. So let's force a shutdown. Boom. See if we can start it up again. There we go. It's up and running. And let's see if we can shut it down again. Nice. Everything works. All right, cool. So now that we have all of this stuff split out individually, that opens up a new venue for us throwing in extra features that can give us, say, some cool player listings, for example. So let's see if we can come up with some way of reading the player information and doing it correctly every time. As I mentioned at the beginning, there could be instances where a player might try to trick our application into believing some specific thing happened by typing it in chat. So in terms of parsing this correctly, we should make sure that we always expect this particular line following the user authenticator. Again, in this case, I know for a fact that the numeric reference. Yes, sir, Pinwheel, we are old timers. None taken, none taken. Um, Sometimes it's good to be an old timer because we were there before stuff started happening, and youngsters, no offense, often ask, how were things back then? Or go, geez, you didn't have IntelliSense? No, we didn't. Stuff like that. Anyway, back on track. I know for a fact that the number reference on the user authenticator is an actual counter. So every time a player joins or attempts to join the server, this count will be increased. No, we didn't have internet either. High five. Good one. Um, So this counter definitely increases by 1 for every join attempt that happens. However, as far as I know, this particular counter is affected by, say, whitelisting and things like whether players have been banned. I'm not entirely sure if every version of the Minecraft server increases the count regardless whenever a attempt to connect is made, or if these counters might be bypassed by things like this server is not public, say it's whitelisted, and when attempting to join from, say, a banned account or a banned IP. Some of them might bypass this counter, some may not. So we don't exactly know how this counter actually works for each individual server type out there. But we could potentially grab that information and put it in a join counter that we could expose as part of the server host class. But in any case, we definitely need to look for the user authenticator thing if we want to build up a list of currently online players. So let's see if we can start by figuring out, say, who's online. And what kind of information can we get? Well, that's actually listed in the logs right here. We can get the actual player name. We can get the UUID of the player. And we can even get the IP that the player connected from. We can get the entity ID, whether that's relevant or not, well, whatevs. And less relevant information is the position that the player logged in at. This particular piece of information is rather useless because whenever a player joins a Minecraft server, the first thing that happens is that player starts moving. Either jumping or actually moving in some random direction. That's just human behavior. So the actual position of the player at login is kind of pointless. The entity ID might be relevant if we at some point decided to reference players by their entity ID instead of their username. Honestly, I can't think of any instance where it might be relevant to target the player by his or her entity ID. So effectively, there's no point in grabbing that information. But it would definitely be interesting to grab the actual player name, the UUID, and whatever IP that player is connected from. We can grab those. For the sake of argument, we could also record the actual timestamp of when this particular player logged on. The reason for doing that could be to set up some kind of online time count for this particular user or this particular session. Whether it's something we will use down the line, we'll see. Okay, so to get this rolling, we should probably figure out a way to store this specific information. So why don't we just do a public structure for that? So, since I can't be bothered with running through all of the different stuff that's thrown up here, I'll just do a regular class and remove all the junk afterwards. Player profile. Boom. There we go. Get rid of this, and we'll do this public struct. There we go. All right. We would like a timestamp. And yes, I need to add the system namespace for that. Login time. We need the player name. Should we do player name or just name? We'll do name. There we go. We also know that we get a UUID. We could potentially do a byte conversion on this if we wanted to. Whether it's useful for us or not, I don't know. For now, we'll just store it as a string. And well, the IP, we have two options or multiple options. We could just save this as a string. We could convert it into a byte array. We could convert it into an actual IP address object. Whichever way we choose to do this doesn't really matter. However, as a personal preference, I think I'm going to convert this into a 4-entry byte array. It just takes up less memory doing it this way. So we'll do this. Public on that one. IP. There we go. Player profile. We might want to do a couple of different overloads on this, but we'll see down the line. Login time. We need the name of the player. We need the UUID as well as the IP. So the login time equals login time right there. The name, let's trim this just in case. And the UUID, same thing. And, well, with arrays, my personal preference is to always make sure that you pre-initialize and then copy it over. You never know what kind of cross-referencing or changes you might run into. So for the sake of keeping things properly separated, we'll do IP length, right, copy from the past IP to stored one. There we go. Job done. And we can do contains the details for a single player's profile. Blah. There we go. All right. Now that we have a container to throw all this data into, we have a multitude of different choices in terms of how we want to store this. We can throw it into an array, we can throw it into a collection, we can do this as an individual variable as needed. We may at some point want to convert this into a class if we want to add some extra features to a given player's profile. There are a lot of things that we can do with it, but for now this will suffice to just store the information. When we get to the UI stuff later on, we may want to change this into a class, but we'll see. All right, so let's have a quick look at what kind of tracing we need to do on this. First of all, we know that the very first piece of information that we get about a specific player is the user authenticator source, throwing us the player name as well as the UUID for that specific player. This will always be the very first instance of some player reference whenever somebody tries to join a server, and this is identical across all the different kinds of Minecraft servers. It always shows up like this because this is the vanilla handler for it. On Forge servers, the vanilla handler is still used to do all the initial server client authentication, or at least identification. So you can always rely on this particular log entry showing up regardless which server you're running. So let's start with this and see if we can actually catch this one. All right, so to do that, we kind of need to figure out if this particular source actually shows up. So we'll add another one to this. Since we know that it will be adding a counter at the end of it, we'll do it just like we did the other one. There we go. I'll grab the text just to avoid my derpy typoing today, and then just do a lowercase of it. So user authenticator There we go. If this pops up, then we know that we can expect to get the player's name, the current name. Keep in mind that through the Mojang accounts, you can easily rename your avatar account name, whatever you want to call it. Some do it multiple times a day and actually pay the fee to do so. I don't get why, but some people do, especially the troublemakers. And the other thing that we know that we can expect to get is the UUID of the player's account, Mojang account. Legacy accounts are no longer supported as of, let's see the date, as of sometime this year, earlier this year, Mojang has discontinued legacy support on Minecraft accounts. So any kind of login from now on will always have Mojang account formats. For our particular setup, that's a pretty nifty thing, because that means we don't have to do two different kinds of user account checking as part of the console parsing. All right, so sample of login, which would be, let's see, now I got my stuff mixed up. There we go. Grab this one and stuff it here. All right. So that's what we actually get in the console from it. We could verify that this is the actual line from it. I kind of like to keep things on a verification level because that effectively removes a lot of the possible errors that could occur if you don't. So, as we all know, assumption is the mother of all screw-ups. Verify stuff. By verifying it, you avoid that particular scenario. Alright, so we know that the initial part of the actual message will always contain UUID of player followed by the player name and then is and then the UUID. So that's what we basically need to split. Alright, we had an instance of us looking for something starting with let's see, that was the done setup, so we could potentially do something similar. We know for a fact that this will always have a specific length, so we could easily substring this, check for it, but I think we'll just do a entry log message to lower index of UUID of player. And for the sake of fully verifying it, we can also do a check for log message to lower index of space is space. There we go. Which would fit with this part of it. So both of these conditions have to be true. If they are, and I could hit the curly bracket instead of the normal bracket, we could actually get some stuff done. All right. Since we're doing a check on the source up here, we already know that we are in here. The log level doesn't really matter, not for this particular setup. And the next part of it is checking that we are actually getting the message that we expect. So from this, we need to split the actual player name and the UUID. So the first one, or the last one, is actually the easiest to do. So let's grab the UUID first. There we go. UUID equals, that would then be the log message. The quick and dirty way of doing this, since we know that the parse console line method always trims stuff, we know that we can do a reverse lookup for the first occurrence of a space and then basically grab it from there. So let's do that. Entry log message last. Whoops. See, I've got the typos in my fingers today. Last index of, look for a space, +1, because we want to start at the first character of the UUID. We don't want to include that. And to get the amount of characters that we need to copy, we need to grab the length of this and subtract that position from it. And there we go. We now have the UUID. That was pretty quick and easy. All right, so we can actually do something similar because we know that we can do this two ways. We can either cut away this, or we can look for the third occurrence of a space, or we could look for this, or we can do a reverse for this and then look for a trailing space, a leading space. There are lots of different ways that we can grab this. We could also grab the entire string and split it into a string array by using the space as a delimiter. We know for a fact that Minecraft names cannot contain a space as part of the player name. It will be converted to an underscore, I think, if you try. So tons of different ways that we can do this. Anyone have any suggestions on which approach we should take? Oh, we know we need one of these at least. So, well, I guess we could just do the reverse lookup on is and then grab it from there. Let's do that. Log message that substring, start from the beginning and then look for the last index of is, and this should be fine. Alright, by doing this we effectively copy this part. The next thing we need to do is effectively cut away this. So we'll do the player name equals player name substring, look for the last occurrence of a space, +1, because we want to start at the very first letter of the player name, and the amount of characters, whoops, last index of the length of the string minus the position that we found. Did my IntelliSense burp up again? I think it did. There we go. All right, so we now have a setup of a proper UUID for the player as well as the player's name. So, yes, last index of. On strings, you have the index of string. You should know what this one is. You always have the index of, which starts at the beginning. You can search for a char or a string. You can add a start position to start at, and the opposite one of these is the last index of, starting at the end of the string going the other way around. There we go. In terms of finding stuff, that's actually a good question, Sir Pinwheel. Will you just keep the list of players logged in based on the server messages, or will you query the server periodically? Well, in terms of handling things performance-wise, since we are always going to get the console output from the server regardless while the server is still running, there is actually no need to effectively ping the server to figure out who's online. That would be the /list command. That would be useful for that. Since we're getting the actual console output, the raw console output from the server, there is literally no need to ping the server to ask who's online, because we already have that information passed to us from the console of the server itself. So this is the initial login part of it. Following this, we'll do the accompanying check for a player disconnecting, as seen here. See, whenever a player is disconnected, regardless whether that player initiates the disconnect himself, or if he, say, for example, due to a network error somewhere, is forcibly disconnected, this one specific line will always show up in the console. If it's a network issue, then it will either be prefixed or postfixed with the network error message, but this particular one line will always show up in the console logs. So we can use this to go through our current online player list and remove that player that just disconnected, because we initially get the actual player name along with the lost connection disconnected message. So there's no need to use Archon to actually ping the server itself. The less hitting we can do on the server, the better, because then the server doesn't have to process that as well. And we all know how slow Java is, so if you can avoid it, don't ping it. Typically, when you go on an engine-based community, it has a plugin that you install on your server that allows Engine to ping the server requesting a list of current online players, which is effectively the plugin doing a /list and then relaying that information back to Engine's site handler, and through that they post who's online on the server on the web page. If we can avoid doing this, then definitely avoid doing it. And since we have the raw console output, no need to ping it. All right, so we've got the player name. We also have the UUID. One last thing that would be neat to track is when the player attempts to join. However, this is the initial step of the login process. The way that Minecraft servers work is that whenever the user authenticator indicates in the console that a player is connecting by reporting that player's UUID, that's effectively just before the server starts sending chunks to the client. When this line occurs, alrighty, have a good walk, Sir Pinwheel. When this line occurs, the chunk sending to the client may still be in progress. It depends on the implementation of the individual server. Some only start by sending the first chunk, which would be the chunk that the player is in, then posts the message, and then sends the remaining view distance based number of chunks to the player. This last one, shared and joined the game, that is the actual chat message being shown, but this is not a full indication of the client actually being done logging in. The client at this state is typically still sitting at the load screen. Which is why new players joining server communities are always sort of greeted ahead of time by both the server and sometimes also the friendly community before the player is actually logged in. So we can't exactly establish when a client has finished its connection process, but at least we can still grab the information. So we can choose whether we want to put the timestamp on the authenticator or whether we want to put it on the following server thread information that tells us the IP. My preference would be putting the login timestamp along with checking of this particular line, because by doing it there, we have a network verification of this particular player being connected to the server. So in my opinion, that would be the better choice. Feel free to disagree. All right. So since we still need to basically pull the server thread to figure out the IP of the joining player, we kind of need a way to check that the next occurrence of the server thread as a source is actually a player logging in. So how do we do this? At the moment we are throwing the player name and the UUID into local variables down here, which means they are inaccessible up here. So we could move them up here somewhere, which would probably be a good idea. So let's put them up here. Player name, and we'll do a player UUID. Kill those. All right, then we will replace them down here with the player UUID. There we go. And boom, there we go. All right, so the only instance where we will actually fill some kind of data into these two is the instance where our source is the user authenticator. Now, since we're messing about with this anyway, we could potentially add in a counter that counts how many connections have been made. Whether it's relevant or not, it's something that we can add in here. So for now, I'll just throw in a note we can also add in a connection counter based on the source, which would be user. And since I'm a super derp at doing the typo stuff today, I'll copy this and change the case. There and there. There we go. Simple thing to do. Cut away and convert to int. Expose as property. Job done. There we go. All right. Note to self. So let's see if we end up having an instance of server thread, which would be here. If that's the done, this would be the stop. So we need to add it down here. Else if, and this is where we need to figure out what to look for. So we already have the username. We know for a fact that this particular string will always show up, so we might as well just look for that and then verify it afterwards. We also know for a fact that it will have brackets in there, so we can do some checking on that. If entry.log message has an occurrence of this, and there it also has an occurrence of an opening bracket as well as an occurrence of a close bracket. Whoops, there we go. Then we can assume that this might, and I stress this, this might be such a line. However, if the server has a plugin that changes how player names are formatted, we could still get the bracket around a player's name as well as the logged in with entity ID at blah. It could happen. We don't know for sure, but that's what we can use our two strings for. See, we've got these two, and we know for a fact that these two have to be not empty when we get to this point. So let's check whether they are empty or not. So if player name has content and player UUID has content, then we can fairly safely assume that the user authenticator has already triggered. So here we then need to split the IP the player is connecting from. Then we need to add this player to the online list. All right, so in terms of verifying stuff, we can even go in and actually verify the username, since the log indicates that the very first part of this particular log entry contains the actual player name. So let's verify that. If entry log message contains an index of our player name, then let's assume this is okay. All right. Cool. let's see. What do we have now? We have the player name, we have the UUID of the player, we need to split the IP, and then we need to add a timestamp of some sort. This would be the next part of it, and that we will dig into right after these messages from our sponsors. Now, I need a quick nature break, so I will be back shortly, and we'll continue this where we left off. Be right back.